is audible. So I'm sharing the screen now. So my audio screen is visible. So let us start with the discussion of today's Codeforces contest. So this was the first question of today's contest. Here we are told that we have two participants in the game, where jellyfish and flower. These are the names of the participants. So jellyfish at AHP and flower is BHP, and so each of them has a knight. Jellyfish has a knight of has a HP of C, and flower has a knight of DHP. So they will play the game in one by one, where jellyfish will be starting first, and if jellyfish knight is alive, he can do attack on either flowers jellyfish or flowers knight, flowers on flower or on flowers knight, decreasing the HP by one. Is either of this, not both of them at the same time. So what and also same for flower. He can either attack jellyfish or jellyfish knights, and it is said that whenever jellyfish or flower's HP is zero, then the other person wins the game. So, so the inputs are ABCD. Here, if you see, A is jellyfish, knights HP, whereas B and D are flowers HP, and D is the flowers knights HP. So here, what is the optimal way? Suppose we have a condition that uh, jellyfish has suppose 2, 3 jellyfish has HP2 and jellyfish knights has HP5, and flowers HP is 5 and his HP is 2. Okay. So what first term, this is for jellyfish, this is for flower. Okay. First turn will be flower. Flower knight is at 5 HP. Now you want to attack. What is optimal to attack? You want to kill him. But what is the best? You can either kill this or this. Suppose he's killing this. So again this one is there. And he wants to now attack. Flower can attack this one. Maximum you have to make this one 0. So he will directly attack this. So it will be become 1. Then the next move, what is the next move? Then it will be 5. So a jellyfish will try to attack flower, where he will try to attack. This one will try to attack. It will become 1. Now it will be 4. So it will try to attack 1 and 0. Okay. So uh, means what I trying to say. So what is this? This was A and this was B. We have to make A 0 or B 0, keeping that C is not 0, and keep that D is not 0 and C is not 0, or opposite cases. This is the optimal strategy. So how to use this? So suppose like in the question you can see, let's take the test case 10, 20, 10, 30. So this is the case 10. His SP is 10 and his SP is 20. So see, he wants to attack this one. Okay, can we attack this one and make it that this keeps non-zero and this will be 0. This at any interval, any interval, this will be constant. The sum will the sum will always decrease by one. Okay, so the sum is always decreasing by one. So what is the optimal strategy to is make this decrease first? Make this one decrease first. So suppose what I can say is something he's trying to kill this one. Okay, he's trying to kill this one, but this is taking out this one. This you are trying to kill. You are trying to make it zero. It will take maximum 20 times. Okay, minimum 20 times. But here it will only take 10 times for him to attack. So better approach is what is the better approach? The better approach is try to kill the minimum of life for the player. Life or the player. See, if you try to kill the knight first, try to kill the knight, then on the other attacks, on the next attacks, he cannot decrease your his any score because he has no knight. So it is optimal to kill the knight. But whereas also can be optimal to kill the the player if he has low HP. If he has low HP. So what is better to kill? So which is the minimum one? So uh, minimum of A and C, and minimum of B and C, B and C. This one we have to kill, and this one I have to kill. This for jellyfish, we have to kill minimum of B and D, and for this one, we have to kill this one. So it will take minimum of this time and this time. So what will how many times it will be is how fast he will kill is which is the minimum. If this one is the minimum, so he will win, and if this is the minimum, then he will win. So this was the direct logic of this program. Is whichever HP is of both the HPs, the player's HP or the knight's HP, which is the minimum one, and we take both the minimum, and whichever whoever the minimum, the opposite player wins. So let's jump onto the board. So I can read it out. I can, so what I said, for, so I will take the input. I take the input, then I will see. I will take the minimum of the first player. If the first player is F1, I will take the minimum which HP is the minimum, and I will take the second player minimum HP, minimum HP. And since the first player is the first one to play, so if they are equal. So first of all, where if they are equal, if the case is equal, so the first one will have the advantage to finish first. So what is the else? Then the other opportunities for flower to. Hope so you understand this code. If there is any doubt, you can ask. If there is any doubt, I hope so there is no doubt, so I'm moving on to the next question. Uh, that is okay. Okay. So in this question, we have said that we are given two arrays. We have just directly we have to find for any index I that we have to find the max of p of pj comma plus 2 of I of j. This is basically a maths problem. So what you can say? What was the equation? Ri equals max of j equals to 0 to I 2 of p pj to I. In this A1, A2, A3, A4, A5. So and this number then B1, B2, B3, B4, B5. So for R1, it will be the max of this one. Just let the function be f of I comma j equals to f of I comma j equals to 2 k power p of I plus 2 k power p of j. Let the function be this. Okay. So R1 will always be equals to f of 1 comma 1. Okay. And R2. R2 we can say it is max of f of 1 comma 2 or f of 2 comma 1. Then R3 is max of f of 1 comma 3 comma f of 2 comma 2 comma f of 3 comma 1. Okay. I hope you understand what I am trying to say. Yes, we have to take this. So you can see you can see directly if we try to compile, if we try brute force. So for every I we are doing I operations, I operation. So the complexity will look like something is for every I there is I is I 1 plus 2 plus 3. So dot n terms will be there. So this is n. So this can directly you can see this is this. So this can also be written as n square complex. So and the constant is up to 10 to the power 5. So n square means 10 to the power 10. It will obviously be p. So there is no need of doing this part. Means you need to understand why this part will not work. So what is the another approach? You can see it this way. We are raising this to the powers of 2. Okay. So something if you don't know, 2 to the power I is something to the power 3. To the power k can also be written as to the power 0 plus to the power 1 plus to the power 2 dot 2 to the power k minus 1 plus 1. This is a basic mathematics formula. Is sum of this 2k of them. This will come to be 2 of k minus 1 plus k minus 1 is the direct mathematical formula. So we can directly say if this does not depend directly on z values, p of I comma this does not depend directly on the sum. Does not depend directly on the sum. You can say if one of the values is greater, is something like is a2 for this section. Suppose for this section A2 is greater than all of this terms. So if this terms here A2 is greater, then it does not affect what is the this other part. Means A2 pairs with this one or this one or this one. It does not affect anything. It is maximum, so this will only be the answer. Because you can see we are taking almost k numbers and add up that also adding one once more, then I am getting this number. This is one single number can equal to the previous k plus one numbers. K is numbers. Okay. So it is so powerful that this highest bit is not so powerful. So we will take the maximum number. We do not need this one. We do not need the other part. Because this is raised to the power 2. It is so much powerful. So then there is one more case. Okay. So see, in this A1, A2, A3, A4, A5, suppose this is the number A1, B1, B2, B3, B4, B4. So this is a permutation of n. This is a permutation of n minus 1. Permutation of 0 to n minus 1. 0 to n minus 1. This is also a permutation of 0 to n minus 1. So basically, it's suppose this is the array. Okay. The max value for the whole array is something say A3. Okay. But on checking that B4 was also equals to A3. Okay. Since these two are same, since these two are same, it may be this pairs with this and this pairs with this. Okay. Since these two are same, it may be that these two may be different. Means these two may be different, and if these two are different, so this one may give this A3 comma B2 may be greater than A1 comma B1, maybe greater, maybe less than, maybe equals to something of this sort. So this for both the indexes we need to check. Okay, means one maximum will be from the 8 index from 8 from the first array, one maximum will be from the B array, and both the maximum must be same. If both the maximum are not same, so we will take the only the miss which is the most maximum one. Okay, because I previously I told you this one because the previous values does not matter, but the same values can affect because can affect this value and this value. This is same, so this and this can affect the overall answer. So if anyone has doubt, they can ask what I'm trying to say. Something. If anyone has doubt, oh, hope so. No one has doubt. So I'm explaining again what I'm trying to do. So some arrays there. Okay, A1, A2, A3, A4, A5, and this is B1, B2, B3, B4, B5. These two are the arrays. Here, what I'm trying to do, I'm taking this one. I mean, for any I text, for B of I, for is for all I, for all I. For all I. Then I'm storing it. And if there is this two, then I'm taking two indexes. If this and this are same, and this both are the maximum, so I'm storing this two and I'm checking this for this up to here. So this pair we know this will be this, and for this pair this will be this. I'm checking which is greater and trying to return that. And if there is only one index, so I'm taking this pair, then taking the sum and trying to do it. This trying to do trying to print the maximum answer. Okay. So this will be only the logic. And if anyone has doubt, I hope so no one has doubt. So another thing for calculation of 2 to the power I, I've used binary exponentiation. This was taught in the coding classes. Hopefully if someone remembers. For binary exponential, you can also pre-compute it as it was before in my template. So I tried I used directly the binary exponential. It is better to use the this one. What I said, binary exponential. The exponential power of is you can either pre-compute it or use binary exponential. For binary exponential, you can either refer to. I am not explaining this. This what I said in the solution. Okay, so let's jump onto the solution. So here you can see I'm taking two test cases. Then I'm directly taking the both the arrays. Then I'm defining the what is the answer. This is the answer array. Answer array. So then I'm taking two indices for a for the first index is the maximum is coming from the first index or the maximum is coming from the second array. So I'm taking two arrays. Then I'm just taking which is the maximum and I'm putting it there. And for this one, first one, first one was first one was only one option. So I directly did. So from here you can check. See if the max is the what was the maximum number. If it is greater than the maximum number, okay. So I'm resetting it. Then I'm checking which what is coming from what. Yes, if it is coming from the first array, so I'm taking first array this one. If it is coming from the second array, I'm taking this one. Or else, if previous something was the maximum, but now again it appeared to this another array, so I'm putting it here. It's for these two lines. Okay. So now here it is. If b1 equals to minus one, this we have not found any maximum from the second array, so we will take from the first array only and else if we have not found anything from the first array, so we will take from the second array only. Or else if we found both, there is opportunity, there is maximum is from in the ith index from both the first array and the second array. So I'm comparing which is more. If the sum, suppose let me understand, if something is 2 to the power 30 plus 2 to the power 30 and here it is 2 to the power 21 and here it is 2 to the power 25. Okay, so which one will move? You can directly say this one will be moved, this one will be moved. Why? Because this is the constant. You can directly cut it, and this is same. If these two are same, these two are different. So if the more higher indices, obviously you take it some, take not the miss. It is better to not take this. Okay, I'm checking this one. Then you can either you can then also the program will execute this part and this part. Okay. So I'm taking just this binary exponential where I'm doing trying to add a binary exponential to it. This one is the add function is mod we have to type an exponential mod also. Okay. Yeah, this one I'm printing this. Hope so you understood. Hope so you understood. If anyone has any problem, they can ask, or else no one has doubt. So I'm ending. Now Pranav will continue from here.
Yeah, am I audible? Yeah, now we have to, in this problem, C, we are given an array and we have to make all the elements in the array equal by performing operations. So we are replacing AI with by taking GCD with some other element AJ. So we have to find the minimum number of operations to make all the elements in the array equal. So, and here the constraints are really important. The number of elements in the array are at max 5000 and the maximum value is 5000 again. So when the constraints are small, like this suggests a somewhat like O of n square or O of n into AI solution because the constraints here are small. So that's important here. And let's understand what is the value with which what is the value that will make all the elements equal. So suppose we are given some array a1, a2, a3. You can take with some example if you want. So 2, 4, and 6. So suppose we have an array somewhat like this. So we have to make all the elements equal, and I now conclude to a point that we have to replace means make all the elements equals to the GCD of all the elements. So here the GCD of all the elements is 2. So we have to make all the elements equal to 2 in the array. So fine, this much must be clear. And if you want to know why we have to make all the elements equal to GCD, then you must understand the nature of the operation here. Like in operation, what we are doing, we are kind of taking GCD with of two elements. This indirectly implies that we are reducing the factors of that number. And once you understand that, whatever number of operations you perform, you cannot reduce the number of factors less than the GCD. So that means that we can only make the all the elements equal to GCD. Like you can try to use some contradiction to prove it, but here it's not like feasible to prove it. So we have to make all the elements equal to GCD. Fine. Now, how we have to make make them equal? So first of all, we'll find the GCD of all the elements. Suppose the value maybe let's say it was a value k. So GCD of all the elements may be equals to some value k. Okay. So now what we can do is simply divide all the elements by k. So we will simply divide all the elements in the array by k because all of them have k, so it doesn't make any sense to keep them. So we'll divide all the numbers in the array by k. Fine, because it doesn't make any sense to kind of like keep the factor k in the elements. So because it does not affect our operations, right? Okay. So once like if any of the element in the array is equals to the GCD, like here in the test case 246, the GCD is 2 and the first element is equals to 2. So when the smallest element is equals to GCD, we exactly need n minus number of elements that are equal to k. This is an edge case basically when one of the element in the array is equals to the GCD, then we can make the array all the elements of the array equal by performing n minus number of elements that are equals to k operations because the other elements simply we can make take the GCD with the smaller element, right, which is equals to the GCD. So this is the a simple edge case, and after that we'll simply do this perform this operation like divide all the elements by k. In just sequence doesn't really matter here, but yeah. So now we will divide. This is the simple edge case explained. Like after that, we'll divide every element by k. Okay. Now we have to kind of first of all make at least one element equals to GCD. First, what we'll do, our target is to make at least one element in the array equals to GCD. We will have to make one element equals to in the array. Okay, we have to make one element equals to the GCD in the array. So in order to make that, what we can do, we have to perform some operations, and we have to minimize those operations. So since like it, now you can understand that there is something like some kind of dynamic programming ideas if you think deeply, because there are a lot of combinations of making GCD one element equals to GCD, right? We have to minimize the number of operations. And if you kind of understand here how we are going to apply dynamic programming, so since we have divided already all the elements by the GCD, we will have somewhat like the, we have to kind of, suppose we have A1, A2, after dividing we have some elements up to AN, let's take. Yeah, we have n elements and we have divided it by k. So we have to find the minimum subset of the array such that the GCD of all the elements is equal to 1. So this is a simple point that I'm concluding here. Like we have to find the minimum subset of the array such that the GCD of all them must be 1. Here we because we have divided it by k, simply we have to make the GCD 1. Like you don't need to divide it here by k, but it's just makes us things clear here or and simple. So we have to find the minimum subset of the array such that the GCD of all the elements is equals to 1. Suppose the length of the such a subset be x, then what will be our answer? Our answer will be n plus, so it took us n of x operations, and now we have to, now n minus 2 plus x, because first of all x operations to make one of the element equals to 1, and after that rest of the n minus 1 elements you have to perform one operation. And but here it will, since the subset has x elements, suppose you have a, suppose they may be b1, b2, b3, and up to bx somewhat elements will be there, and in order to perform operations it will take x minus 1 operations, because it will take x minus 1 operations to take GCD, because we just have to means n minus 1 x minus 1 operations. So x minus total operations would be close to this will be the answer. So now we can find the minimum subset by using dynamic programming. So how will we use dynamic programming? So let's define the dynamic programming state here. So the dynamic programming state will be I comma j. So let's try to think in the 2D DP. So this is minimum number of elements in the subset such that all the elements is equals to j. So minimum number of elements in a subset such that GCD of all elements is equals to j. This is the state, minimum number of elements in a subset, and considering the subset from the sub array, understand the state, sub array from I to n. Like this is up to you. So minimum number of elements in the subset such that GCD of all elements is equals to j, considering the subset from the sub array I to n. Like I want to know if the dynamic programming state is clear, but I hope this is clear. This is clear. And how will we compute the transition here? Like this must be the dynamic programming state. So this is the DP state here. Yeah. So now what will be our transition? DP transition. Okay. So how, since the range of elements here is really small, we can go for first for loop will be simple n iterations. Second for loop we can go for j from 1 to 5 5000 possibly. Yeah. And now what we know, we can simply say dp of I comma j is equals to min of dp of I comma j. So and dp of I plus, we are iterating backwards, this is really important, for I from n to 1. So we are iterating I from backwards. So we can simply use I plus 1 here. So this is simple. The first thing is we have already got the smallest subset. Then we have to consider that smallest subset that we have got ahead, right? Okay. Now what if that subset has the AI element? So when the subset that has the AI element, then what will happen? I mean like, okay, this is simple. First step is simple. And now what if we are going to, I mean like, basically we have to take GCD of AI. This is simple first case. What if AI also has some role in that? So when AI also has some role, you can find the GCD of AI and J. This is the value. Okay, this is the GCD. So after we take the GCD means we are applying the operation with AI, and this will be some value. Suppose this is some value. Okay, I mean like, what I am trying to say is this is some value which we have already got in the forward subarray subset, and we have got a new value after taking the GCD with AI. So dp of I comma this value will be what? Minimum of dp of I comma value, and we have applied one operation here, and previously we have got that value j. We already have the subset that has a GCD value of j ahead, and then we are taking the GCD with AI to get another. I mean like, yeah, we are basically making the GCD now equals to value, right? I hope the transition is clear. Like this is the another thing. This is separate and this is separate. So this is simply the transition. And finally, what will be the answer here? So the x here will be dpi 1 comma 1. Simple. And then we can simply print out the answer n plus x comma 2. Uh, yeah, 2. So this is the simple solution. And I hope this was clear. Yeah. I just want to know whether it was clear or not. Yes. Uh, I hope this was clear. So let us move into the implementation. Okay, so another important step here is, so when here what we are doing, we are finding the GCD every time. So GCD costs us how much operations? Approximately log n operations. So here how much is log n? Log n can be log of 5000. This will be what? Approx 10. So if you kind of consider the worst case scenario, then it may give TLE, because the GCD every time you are performing GCD, we are not sure about how many operations the GCD is going to take. So if this was taken to be 10, then 50,000 into 5,000 into 5,000. times of 10, this will be like greater than, I guess, 10 to the power 6, 10 to the power 7, 25 into 10 to the power 7. So I think this much, this is what it's. So this is a TLE. Like, I'm considering the worst case scenario. This is a TLE because I guess this looks like a yeah, this should be TLE, I guess, like closely to TLE, because 2 seconds is the limit. So we can, what you can do is you can pre-compute this GCD if you get TLE here, because this can grow large in the worst case. So that is another case. So now let's move on to the implementation. So what we have done here is taken the input. First of all, let's take look at the pre-computation. So this is simple pre-computation. We pre-compute the GCD of each and every element since the range is really small. So 5000 to 5000. This is simple, and we have stored it globally. Pre. Okay. Now we take the input of the array, and after that we compute the whole GCD and divide every element by GCD as I've mentioned in the explanation, and count the number of elements equals to 1. This is like the edge case when, so if this count is not equal to 0, we'll simply print the n minus cnt, and else you can use the set, or it's up to you, like you don't need extra elements, then you can use set. So how, if the constraints were like the range of n was increased, then maybe the using the set would have been feasible, but here it's not necessary. So this is simple. We have initialized the dynamic programming to infinity every state, and this is the our base case where we can produce the subset having this the last element equals to 1, because the one element is equal. So this is first of all having the single element subset, and then considering taking the minimum with the previously calculated subsets, and then considering the current element to be taken. And we, since we have already pre-computed this GCD, we'll use that value and simply update the state. Transition here is applied, and then we'll simply print the answer like n minus 2 plus x. uh, I hope the explanation was clear. If it's clear, then I'm saying